So the first concept that we're going to talk about today is important so that you have a good conceptual model of what is happening in C#. You may have potentially intersected with this in Python. I'm not sure. But I think C# is a little different, and I want you to be able to hold this in mind, because if you don't realize this is what's happening, you'll get into some weird spaces, errors, where you're like, this should work. Why isn't this working? This is bizarre. And it might feel bizarre, but it's the way C# is designed. Okay, so there are two types of types: reference types and value types. Was this covered in the videos? I feel like he probably would have said reference types at some point. Negative? Okay, good. So let me give you an example. This, on the whole, the simple types, the primitive types, like integer and bool and character, float and double, those are value types. The variables of those data types hold their value. So if you were to look in memory, deep down in memory, if you had integer a equal 42, there would be a 42 in memory at some memory address. And I've just made up some number, 64. So this is address 64 in memory. This is your memory, all the bytes of your memory, the RAM on your computer are numbered. They would go from 0 to as many gigabytes of RAM that you have. If I say int b equals a, then because integers are value types, we actually make a complete copy, a complete clone of the value that's here, 42. And so now there are two 42s in memory, one at address 60 and one at address 64. Okay? So on the whole, I would think this is how you would expect it to work. And it does work this way for the simple types. When you make a copy of an integer, you make a copy of its value because it's a value type. Not all types are value types. Some types are reference types, and that means that the variable holds a reference. It holds an address, not the actual value. So let me show you an example of that. String is a reference type. So it's the string and object are the two built-in types that are reference types. Any classes that we write, which is what we're about to learn next, will also be reference types. If you create a string s is equal to Hulk, there will be H-U-L-K. Oh, I'm sorry. This should be lowercase h to be the same as what's here. That's my bad. So that's out here in memory, and I've made up some memory address, 576. So the letters H-U-L-K are at memory address 576. Yeah? String s is this variable that's at address 72. I'm just making up numbers, but it's at a different memory address, and the value that it stores is not H-U-L-K. It's the address where those letters are, 576. So it's as if it's storing an arrow, storing a reference to where the thing actually is. It's not actually storing the data. When you access it, you don't have to jump through any hoops. C# knows how to do this, and if you want to do anything with that, it's going to automatically jump to the address where the data actually is. But if you make a copy of S and store it into T, something potentially unintuitive does happen. It actually does what happens over here, which is it makes a copy of 576. So at memory address 68, there is a 576. At memory address 72, there's a 576. You'll notice there's only one Hulk. There's only one Hulk. You with me so far? So this means that S and T actually both point or refer to the same thing. And that means that if we were to change S, then we would also change T. As in, if we were to change Hulk here, then they would both be pointing at it. So what I want you to take away from this is, when you're dealing with reference types, which would be strings and any object that we make, it doesn't actually make a complete copy. It doesn't clone the thing. It just has another memory address reference to the thing. And the actual kind of like data of the object only exists once. Okay? So sometimes you can get in some weirdness when you're like, but I made a copy of that thing. Why isn't it the same as what I thought it would be? And it's because you changed it because you had two references to it. So if you had two references to the same list, this works better for lists because lists are mutable. If you have list A and list B and they're pointing to the same actual list in memory, if you change list A, you've also implicitly changed list B because there's only one of them deep down. Okay, so basically all of the built-in types except for string and object are value types. So the basic types are value types, and then string and object, also any class that we make, are reference types. And then there's one more here, which is struct. And struct in C# is essentially a class that is value type. So if you actually want to make a copy every time you say equals, whenever you make an assignment, even if you've got some really complex, like student object, a building object, a cart item object, that has lots of stuff inside of it. Remember classes and objects? If you make it a class, the compiler will treat it as a reference type. If you make that thing a struct, the compiler will treat it as a value type. So you are in control, and you can have either semantics, either meaning that you wish, even if you make your own class. But it would be a struct if you want value type. All right, so we may run into that later, but I want y'all to have that baseline information. All right, now for the bulk of what we want to talk about today. This is essential foundational information to operate in an object-oriented language. We have to have objects and classes. I know, it was unexpected. One thing that I would like to point out is this high-level overview of objects and classes. In my mind, one metaphor that I like is a class is a blueprint. You know, like a blueprint that you might use to make a building or a house, or even a blueprint for some widget that you make in a factory. You with me? It's like the design of all the measurements and all the things about the thing. Notice, if you have a blueprint for a house, do you have a house? You do not. You can make a house, but you don't have a house. You have the shape of a house.
How's it?
An object is the house. So when you take the blueprint, the class, and actually make an instance of one of those, that's what an object is. It's like a living, breathing version of the blueprint. The fancy word for that process, one of the fancy words, is instantiation. Do you know this word? When you create an instance of a class, or an instance of a class, you've then brought it into being. It has its place in memory, and it exists as more than just a blueprint. So we have classes and objects, and that's the relationship. On the left in the screen, you see how you define a class in Python to the best of my ability. Does this look sort of familiar? On the left, we have a class named student. It has this thing called init. Init is special. It has a special word called, anyone? It does have this self in here. Do you know what the whole init function is called? It's an initializer, and the special word that most object-oriented languages use is constructor. Did you ever? That may not be the Pythonic word for it, so apologies. In C#, we're going to call this a constructor. Notice over here, the constructor in C# is always the name of the class with parentheses. So that's the C-based convention, whereas Python does this weird thing where it has the double underscores. Yeah. Okay, let me come to that. So C# says you have to be explicit about the access level of every member of a class. So the main three, I think this is maybe the next slide, are public. That means you can access the thing outside of the class, publicly available. There's also private. Anything that's marked as private, you can only access inside the class. So if you're outside the student class, if you're using the student class in your program, you can't see private things. It's as if they don't exist. Only the student class, when it's the methods in the student class, could see and use private methods or private fields. Okay, great question. C# is all about data types, and you got to be explicit about data types. So if you have a method that doesn't return anything, then you have to label it as void. If it returned an integer, then you'd say int. If it returned a double, then you'd say double. But in this case, you've got to label what kind of data gets returned out of the function. If it returns nothing, there's no return statement, then you have to call it void. Good question. Notice this, too, that this is the way you would define fields in Python. You just say self dot and then whatever name. C#, you need to be explicit about that, and you declare what these fields are. So, and I'm also, in addition to giving the name, fname, and the data type, which is a string, I'm defining its access level, public, and I can give it an initial value if I want to. I don't have to give it an initial value. Question? This is self. Self is this. So in most C-based languages, this is the keyword that means this is a reference to the current object that you're in, just like self was in Python. So you can exactly replace self with this. So in this case, I'm saying get the GPA field that's in the current object, whichever object this code is running in, and set it equal to the result of do math, which isn't a function that I listed here just because there's not space. You'll notice, well, I kind of messed that up. I should just fix it. Thanks. In C#, the convention is that methods should be in uppercase letters. So probably the D in do math should also be uppercase. Oh, I'm sorry about the captions. I hate the captions. Sorry. So let's just remind ourselves what we just learned. We have a class that defines the blueprint of an object. Classes basically have two things. They have fields, which is a fancy word for a variable in a class. So in this case, we have fname, lname, and GPA as the three fields. Fields have lowercase letters to start with in C# by convention. In addition to fields, which are like variables, we also have methods, which is the fancy name for a function in an object. Yeah? This particular class only has one method, which is the compute GPA. In addition to that, classes have a special function called the constructor, which initializes the object. At the moment, this constructor does nothing. A lot of times you'll see it set initial values or create other objects or memory that it needs to have. I could have done this, I guess to be most similar, I could have set fname equal to quote, quote, lname equal to quote, quote, and GPA equal to 4.0 in the constructor. That's when it happens in Python. C# lets you do this thing where if you have fields, you can just set what their initial values are here. And I think it happens, I think those happen before the constructor actually, where the field initializations happen. So just a little bit maybe more readable, that those don't have to be. Initializing fields is simpler, and you can just write it like this. Yeah? Okay, thank you for looking out for me. I appreciate that. So this is how you define a class. We typically would put classes in their own file that have the same name as the class. So by convention, most of the time we'd have a student.cs file that contains this. And that's just an organizational pattern. How do you create or initialize or instantiate an object? How do you bring one to life? The Python way looks like this. The C# way looks like this. The essence of it is you have to have this new. The new keyword is telling the compiler, run the constructor of some object. Run the constructor and create a new object that actually has memory. What's going to come on the other side of this is the constructor, which is the name of the class with parentheses, just like in Python. And we will see there's actually some improvements, some convenience improvements to this, where new C# lets you write this with less redundancy. More on that in a second. But here's the kind of prototypical way. Here's what I mentioned, access modifiers. Certainly your big two are public and private. So this is the words that you would put before every field or method or property, as we're about to learn, to say, can programmers or can classes outside of this class access this thing? Can they see it? Public means yes, you can see it outside the class. Private means only this class. If you don't put access modifiers in a class, private is the default. Okay? So if you don't put it, they are private. You just didn't say it. So this is supporting a big word that's important to OOP. I'm not sure if you all have run into it yet. So I'm going to write it in red. Have you heard of this word, encapsulation? Three times. Good. So now it's four? Okay. So encapsulation is a really important concept in most object-oriented languages, and this is a very, very real way, like, to me, the most slap-in-your-face way that C# does encapsulation. If you mark something as private, if it's private, you can't see it at all if you're outside the class. Python doesn't enforce this strongly, which is weird to me, because this idea of, no, I want all this to be private, to be secret, is a really important part of making large-scale systems so that somebody else doesn't come in and mess up the internal state of your objects because they don't know how everything works. You, the person who wrote the class, does know all the intricacies, and you're keeping all that kind of the ugly guts inside of it, and nobody can mess it up when you mark it as private. The third one, just for completion, when we're about to learn about inheritance. Inheritance is when you got a parent class and a child class. a superclass and a subclass. Are those the words you used before? Okay. If you want a field or a method or a property to be accessible to children classes, then you need to mark it as protected. If you mark it as private, even your children classes can't see it. So it's kind of a middle ground between public and private when the thing is, when inheritance comes into play. There are a couple more access levels, like internal, that have to do with like internal to a particular namespace. But these are the three that I see used most often. Okay? Okay, so I want to give you the full picture here. Do you remember that I said before classes have two things? They have fields, which are like variables, and they have functions, which are called methods. That was a lie. There's actually three things. But the third thing is basically the child of a field and a method. It's like they came together and had a baby, and the baby is called a property. So a property is a smart field. It looks like a field from the outside, but internally it acts like a method. So we can write logic, but then have the logic run when we access what looks like a field. We'll see here in the next slide, the way that we implement this is with a special function called a getter. The getter gets the value out. So whenever you read from the property, the getter gets called. Whenever you write to the property, the setter gets called. So instead of just straight dumping the value, copying the value that somebody else, some other part of the program gave you, the setter gets called and can run logic to make sure, to enforce control. So you have, so the why do we do this? To have controlled access. Two things here. One would be to enforce validation rules. So we could make it so that if somebody ever tries to put a negative number as your age, we say no. We're going to throw an error. That a negative number makes no sense for a person's age. We won't ever even allow that value to be put in. Does that make sense? Another example would be like if it's an email address, if somebody tries to store an email address and there's not an @ sign in it, we know that's wrong. So we can just not store that value. So from the beginning, as soon as we try to assign in, which is calling the setter, we say no. So properties allow us to do encapsulation with all the power of any logic we want to write. We have simple access. It looks like a field when you read or write to it externally, but we actually have all of the control. So this is what this looks like, and I know this may be a little bit cumbersome. Looking on the left side, I've got my class student, but now instead of making, I still have this first name field, and notice that first name is lowercase. So this field, this is just a plain old variable. What I've wrapped around it is a property called first name uppercase. Properties by convention are uppercase. Notice the field is private. The property is public. It still is a string data type. But what I've written inside here, inside these curlies, is a getter and a setter. So this get accessor has to return whatever the current value of first name is. At the moment, it's just whatever's in this. The setter, likewise, has a special value called value, and it's whatever somebody passed in to set this property as. And in this case, we just set the first name field equal to the value. So this example does not show validation, so you might even say, what's the point? We're not even doing anything here. And that's a fair assessment. There's actually an easier way of writing this if this is what you want to do. If, for example, we wanted to say, we will not allow anyone named Brandon to be stored in our system. Brandon is not a legal first name. Okay? Then we could very easily in here have an if line. Hang on. It's hard to code in PowerPoint, but we could say if the value equals Brandon. Actually, let me do it this way. If the value does not equal Brandon, then we set first name equal to value. If the name is equal to Brandon, we just don't do anything. So this is an example of this validation. You see, if this were just a field, first name, like I had on the previous slide, you have no control. People can store whatever they want to in there, even really unreasonable things. Does this make sense? So this gives us more control, where we have a publicly accessible field, but perhaps we can't just make any changes we want to, because we get to control the logic here. On the right side, you see how to use a property, which this is really easy. If you want to get the first name property out, you just say dot first name. So in this case, you couldn't really tell, is this a field or is it a property? It looks the same. And likewise, if I want to set the first name to be Joe, I just set it, just like I would expect to set a field. So you can't even tell that you're like calling the setter. So this is a core thing to C# because it really makes it easy to do encapsulation, validation, control. And so we'll be using this like almost exclusively, and we'll have very few actual fields. If you just have plain old regular properties that you're not going to do any validation, that you can let the compiler do the work for you, and these are called auto properties, and we'll use this a lot, where you just say get semicolon set semicolon, and it creates the backing field for you, where the backing field is what I had as lowercase first name in the other one. And this is the proper way of doing properties, even if they're, like I see how this is effectively equal to a field. But we're going to always prefer to do it this way in C#. One more thing that I don't have a slide on is you can actually have more control over the getters and setters. If you want to, you can not have a setter. If you don't have a setter, you only have a getter, then you have a read-only property. You can only read from it. You can never write to it. So this would be something that actually comes up a lot. Like if you were going to say like GPA, let me just do that here. GPA is probably something that we don't want people to set. We want to always compute the GPA based on on the students' classes. So you don't just get to say they have a 4.0 GPA, which breaks this. Instead, there is no setter. So instead, in here, we could return compute GPA, where, thank you. Should probably be a different slide because it's a new concept. I need a semicolon there, here, and hang on. This is the getter. I don't like the way this is spacing. Do you see here, this getter does math. It computes the GPA. So instead of storing it, I'm just going to always compute it when somebody asks for it. And this way, it's always like the correct version. So if somebody had, like, it's not here, but if somebody had added a class, changed their new grades and come in, this would just compute it and not store it. So you see this pattern a lot as well. I want to code in VS Code and not in PowerPoint. PowerPoint does not know how to do this. Okay. It's annoying, right? That's probably a setting somewhere. I should unset it so I don't have to turn it off every time. Okay. A couple more ideas before we switch into code. What we've seen up to this point, and what's probably most common, is to use instance members of a class. If you have a first name, last name, GPA, as we've got down here, these would be called instance methods, and that means every instance of the class has its own copy of first name, its own copy of last name, its own copy of GPA. These are like standard object-oriented, the way that we would do members. Members is the general word for properties, fields, and methods. Sometimes it makes sense to have a method or a field or a property, a member, that there's just one of them for all of the objects of a particular class. And here's one kind of goofy example. If you wanted to know how many total students there were, you could store that as a class variable. C# calls it a static variable. So a static variable means there's only one of those. So there's only one spot in memory that's storing the number of students. You'd have to actually increment it in your constructor to say number of students plus plus. I should probably have done that down here. But what I want to emphasize is that unlike all these other objects where we have a first name and a last name and a GPA, and we have a first name and a last name and a GPA, right? There's this memory for each of those. That number of students, as I imagine it, is out here. Since it's static, there's only one of them, regardless of however many instances I make. It only has to be stored once. And likewise, then that number exists, number of students, that variable, that field exists even if there are no instances of the class. So it exists before the class is instantiated. In the same way, if you have a variable, if you have a method that's static, then it can exist before any instance is instantiated. If we had a compute GPA method, you couldn't call compute GPA until you instantiated one student to compute their GPA. But if you had a static method, you could run that static method before you have an object of the class. And the way that you would do that is say, name of class, in this case, student dot static method. All right, we'll look at that a little bit more later when we have a good reason to use them. Okay, let's open up Visual Studio Code. Open a new window, and I'm going to create a new project by going to my folder, creating a new folder. I'm going to call it OOP Goodness. open this blank folder. And then, as I recall, I can Command-Shift-P and create a new .NET project. We could also do this on the command line if we prefer. I'm going to do a console project once that template is discovered. I'm hoping that I can do it. I want to do it in this folder, not make a new folder. Okay, so I want to make a new console app. You remember going through this before? And name the project. I wonder if I name it dot, if it'll know that I'm in the current directory. I'm going to try it and see what happens. Oh no. Well, let's see what it does. Don't be like me. I now have a project named dot. So I have a .CS project and a .dot solution. Okay, hang on. Redo, Command-Shift-P, new project. I want a console project. I want to call this OOP goodness. I do want to choose this default directory, which is the one that I'm in. I want an SLN, not an SLNX. Show all template options. Oh yeah, I do not want to use top-level statements. So I'm changing do not use top-level statements to true because I want to actually have that top-level program. And then create project. And this has created the subfolder that I don't want, but that's what I got. Sorry. I don't know, maybe I do want this. So there's the solution file, and then the project file, and this .vs code. The .vs code folder, any folder that starts with a dot is hidden by default in Mac Linux. Is it hidden in Windows? Okay, so I'm going into this OOP goodness project, opening the program.cs. And now, because I've made that top-level statements don't use top-level statements to be true, I have this class program, and the program has a main, and it has this hello world. Notice this is a static function method. Why is it static? Because this function has to exist before you instantiate the program class, because this is the starting point. So this static void main exists before you've created an instance of the class program. Does that make sense? Joshua. Command-Shift-P, .NET new project. And then console app. Console app. And then enter a reasonable name, like OOP goodness. Not console app 1. It's a terrible name. Choose the default directory. Go down to show all template options. Did you get that? Show all template options? No? Okay, do SLN. Okay, and then go down to do not use top-level statements and set it to be true. Show all template options. Show all template options. And then do not use top-level statements. Okay, So I'm in this folder that is my project. So I've got to be in this folder. I'm going to right click and say new file. And what is it that we know the most about? We know the most about being students. Oof. Students are so boring. What's that thing y'all were telling me about? Y'all were getting all into? Fortnite characters. That was fun. So let's create Fortnite character.cs. Fortnite character.cs. And let's see how to make this. So I'm going to say class Fortnite character curly. And can we come up with what are 2 or 3 things that Fortnite characters have, and maybe 2 or 3 things that they do? They walk, they move. Okay, I'm going to say we have a public void move. And I'm going to console.writeLine, I'm moving. So that's how we're simulating that. What does a Fortnite character have? Do they have a name? Do they have? Yes. So they have a name. So we would say that they have a public string name. And I really want this to be a property. So it should have a getter, get semicolon, set semicolon. If we're being good and we want to make that yellow line go away, we should give it an initial value of quote, quote. Quote, quote is the empty string, which actually is a string that has no content, which is different than null. It will be null by default. Okay? I'm really hoping for some like simple primitive data types. Is there anything that could be a double or a Boolean or another string that is an essential thing to store about a Fortnite character? They have a backpack? They always have a backpack? Okay, perfect. So we have a public bool has backpack. So that's got to be true or false? Nope. And is it one of those by default? Is it true by default? False by default? False. So maybe let's be really clear about this and say equals false. So when nothing happens, that is when we instantiate one of these Fortnite characters, that will be false. And their name will be quote, quote. Okay. This is a good baseline. Let's move with this. Okay. So notice these are properties. We know they're properties because they have getters and setters. Would this be the name that you set? This is preset in the game. Or is that different? So the character has a name, and then when it's being played by a person, there's a username that is playing that character name. Okay, so I'm saying this is that's an interesting relationship. So multiple people in a single game could be playing the same character? Okay. Let's look at this. Let's make a constructor. You guys remember constructors? A constructor is the initializer. Actually, pause. Let me show you this. Writing properties is super common. There's lots of times when we're going to create properties, and they always have this format. The property is always going to be public because that's the point of being a property, is that it's accessible outside the class. It has a data type, and it has a name. In this case, the name is name. Yeah? Since this is so common, there's a snippet that's built in. If you say PROP, you see that short for property, and then press tab, it expands out to be a property. So if we want this to be, we want to change the data type to double, and then press tab, and instead of being called my property, is there some double that's reasonable here, like hit points or life or XP or something? What would be some stat that you would, is there a core stat? Was that health? Okay. Spell it right. Okay, so we've got public double health. I just wanted to show you here how you can, you see this, to me this shortcut is really helpful. So PROP, tab, and it's just going to do an auto implemented property. Here's a good one. I suspect that health should probably, let's say your health actually can't be set. You take damage, and when you take damage, then your health gets decreased. So I'm going to say from outside the class, you don't get to change the health. Instead, there's a function, public void take damage double amount. And externally, if someone, when you take damage, the system would call take damage. And here we're going to say health equals health minus amount. Oh, okay. So what I've done is actually locked myself out. Since there is no setter, if health really is only read-only, then I can't ever set to it. That's not what I meant to do. And this is a new thing I wanted to teach you. You can actually here say private set, semicolon. So private set means the setter is private. The getter is public. You can read health from outside of it, but you can't change the health from outside of it. The only way that we've allowed the health to be changed is inside take damage. So to test this, here's a decent baseline. Yeah, we should stop here and test these properties. So we have a Fortnite character. Let me put one more thing in just so you can see this. If I say that there's a public string, is there something that is like secretive? That you don't need to know outside this class? Sorry, this is an artificial example. Public string secret value equals 42. I know this is no relation to the game. I'm sorry. We'll find a reasonable way to do it. What I wanted to put in here, oh, not public. I want to be private. I wanted to show you one private member. Okay, so this is our Fortnite character. Now I'm going to go to program.cs. And now I'm going to use some Fortnite characters. So here I want to say Fortnite character. Oh. Look at this. What's happening here? It doesn't know what a Fortnite character is. What's going on? I bet if I hover, it can say this. Type or namespace Fortnite character could not be found. Are you missing a using directive or assembly reference? So this is our naming issue. Notice that class program is in namespace OOP goodness. Fortnite character doesn't have a namespace, which puts it in a different namespace. So I want to take this first line, the namespace OOP goodness, and put that in my class file so that this file, Fortnite character, and program.cs are in the same space. So basically they can see each other even without having to import anything. So I think now, let me see if I can't start typing again. Fortnite character does come up because it can see that that's in the current namespace. So a Fortnite character, can you give me a space, a name? Chumley? How do you spell that? What is? Can anyone confirm or deny this? It's really important that we get this right. This code's not going to work if we don't spell this right. Okay, so really, I'm just trying to make a variable name. It's going to represent this character. The next thing I'm going to do is say new, because I always want to have a new before I instantiate a new thing. And I do want to create a new Fortnite character, calling my constructor, parentheses, semicolon. Yeah? Yep. Okay, then you just watch and we'll catch up afterward. Okay, so notice now that I've instantiated this object, when I say Chun-Li dot, do you get these things that pop up? So this is IntelliSense showing us what are the things that this object has or can do. Notice, and we'll come back to this, equals get hash code and get type were not things that we wrote. Where'd those come from? That's weird. Hold that thought. Has backpack is something we wrote. Health is something we wrote. Move, name, take damage, and to string is something we didn't write either, but looks like we have something. So I can say dot has backpack equals true, and then change that property. I can change this variable's name. Is it this? First name Chun, last name Lee, or is it one word? Okay. Semicolon. Notice if I say Chun-Li dot secret value, secret value, we definitely have a private string secret value, but when I try to call it, the compiler says Fortnite character.secretValue is inaccessible due to its protection level. So this error means you were trying to access a private variable or maybe a protected variable. You can't do that from outside the class. From inside the class, we can easily do that. So if, for whatever reason, I wanted to change the secret value, I don't know, I'm going to double it every time he moves. So that would be times equals 2. Oh, wait, it's not a... Hang on, I'm going to change it to be a double so that I can do math. You see that within the class, I can do whatever I want to this variable. But from outside the class, it's like it doesn't exist. That's a compilation error. This code won't run because I've got that. So I'm going to comment that out. Let's see what happens if we say .move. let's print out Chunli.health, and then let's call Chunli.takedamage. Wait, did we give them a starting health? We should probably do that. 100. So here I'm using this field initialization or property initialization to just set it equal to 100 when it gets created. You see that here? So that's the initial value. And then I would like to repeat this statement, the console.write line. I would like to run this and just confirm that it works before we dabble in a constructor. So you remember we want to say .NET run to run our program. Of course, we can't find a project to run. So I have to say .NET run -- project OOP - goodness. It's annoying if there's just one project. It seems like it should know just run that one. So this was my command: .NET run and then -- project and then the name of the project. So I have an I'm moving, a 100, and a 95, which is reasonable, right? Because we said take 5 damage, and then we printed out our health again. Okay, we're good? Something else we probably want in most classes is a constructor. You'll note here, that is a constructor. Did we write a constructor? There's nothing called Fortnite character parentheses parentheses. What's going on here? And the answer is the compiler writes an empty constructor for us to just create the thing and not do anything else. So for free, we get this. If we want to be in control, like sometimes we would like our constructor to set initial values for things. If we want that to be the case, then we've got to write it. So I'm going to come in here and I think what I like to do is put my properties first and then my constructor after my properties and then methods after that. Because I like to see, okay, what is this thing? What are the properties of this object? And then how do I create one? So to create a constructor, I'm going to say public Fortnite character, parentheses, curlies. I spelled it right, didn't I? I spelled it wrong. Okay. I don't need the void. That's what was throwing me off. Okay, so there's my problem right there. So I'm going to change the name of this to be correct. Fortnite character, which now this is Fortnite character, which now this is Fortnite character, and this is Fortnite character. Okay, my bad on that. Okay, this is a constructor. The constructor is always the name of the class with parentheses. There's no return type. So it might be the case that within this, I would like to accept a string name. Notice that's little n name. And I would like to set the big N name, the property, to be equal to whatever the user passed in. So that when this is making it so that when I create a Fortnite character object, you have to give it a name. Does that make sense? So now we'll have an error over here. Because now I've tried to create a character and there's no name. And you see, if you hover over this, you see the error. There's no argument given that corresponds to the required parameter name. Now certainly, like I'm for the, you can look into the quick fixes, but sometimes the quick fixes do not recommend reasonable things. In this case, they want me to make a new constructor that matches this empty constructor, which is not what I want to do. I want to fix this one. So basically, I need to give it a name. So the way I would want to do this here is to pass in the name here, in which case I don't really need to do this, right? So if there is something that, a property, a field that you have to have up front just for the object to exist, and sometimes that makes sense, depending on what it is, that it doesn't make any sense to not know this up front. Then you can pass this in, and this is maybe a little bit cleaner. Does this make sense? While we're on this constructor idea, you can also pass in something like has backpack, which I need to give a data type here for, which would be bool. And now, when you create the character, you have to pass in false or true. Do they have a backpack? Notice we're accepting the parameter here, but I didn't do anything with it yet. So down here, I need to initialize it to say capital H has backpack is equal to little h has backpack. Notice that I'm naming the parameter the same name as the property, but lowercase. So that they're two different variable names because case doesn't matter. Notice this is bad form, but I'm going to do it. If I make this uppercase, then at this moment, within this constructor, there are two things called has backpack. There's this parameter has backpack, and there's this property has backpack. You see how there's two different things? There's the variable you pass in, and the one that's a part of the object. For one, you shouldn't pass in parameters with an uppercase H, but if you find yourself in a situation where you do have this, it's called name hiding. This one is hiding the other one, because in this scope, the parameter is the one that's closest. So it overrides, as it were. However, we can disambiguate, we can clear this up by using the this keyword. And if I say this dot has backpack, then I'm definitely talking about the has backpack property that's a member of the current object, not the parameter that I passed in. And you could do that here as well, even if I did this. I know sometimes people will, if this helps you keep in mind what's happening, hang on, this is more reasonable. If I want to be super clear, the thing that I'm setting is the property, and it's the property of this, which is the current object. Maybe this would be easier if I started by this dot. And by saying this dot, then you get IntelliSense autocomplete of all of the things that are in your class. But as soon as you do this, and I'm sorry I'm using this so much, can you tell that this is kind of grayed out? Because it's saying, you can simplify this. You don't need this dot here. You can say quick fix, remove this qualification, and that's equivalent here, because you don't need the this to say which one you mean, because they're two different names. Same for down here. I could say this dot health is equal to this dot health minus amount, if you were wanting to just reinforce of the current object. But neither of these thises are required. Okay. Now, when you come over here, we have an error again. Why do we have this error? It's because I added has backpack, but I didn't give it a has backpack. So at this point, the only way to create a Fortnite character is to pass in the name and the has backpack parameter. You have to pass in two things. Maybe that's annoying, so let me teach you one more thing about constructors to kind of round this out. Sometimes you would like to give parameters a default value because you kind of know, basically, this parameter is optional. If the user doesn't give it, if the programmer doesn't give it, just use the default value. So here, I'm going to say false is the default value of has backpack. Did y'all use these in Python? Optional. So it's the same idea. I think it's very readable. If this helps your life be easier, then do this. Now, over here, the one parameter name is required, and it's up to me if I would like to pass in a true, I can do that. But if I don't pass in the true, then it defaults to false because we said that's its baseline default value. So by creating these constructors that have reasonable fields, properties that we would like to initialize, it ends up, you're creating an object that helps you really build some bigger system. Like again, all this is pointless, but what we did here, but the idea is that if we were really going to model Fortnite, there's going to be player characters and Fortnite characters and weapons and like arenas, and all those have different things and they are composed within each other, they interact with each other. It is too much to think about all those things at the same time. And objects, I want us to ground in this, so this is a good ending. Objects help us deal with complexity through abstraction of kind of getting away, not having to think about all the details all the time. That helps us manage the complexity. By encapsulating the secret inner details inside and just knowing public details outside, it helps us to not mess stuff up because we can only interact with the stuff that the designer of the class said we can mess with. So this way we can make more complicated stuff. I'll be sending you out some videos for next week, but I would like y'all to work on that practice exercise. Is that feasible to get done this weekend, or we need to have one more day to chat in class? Let's make it due Tuesday, at the end of day Tuesday, but definitely we can't extend it from that. But I want you to like work on it, bring intelligent questions to Discord or email me, and let's make sure we're making progress on that. Y'all take good care. See y'all.